Alrighty, welcome to another CS for Beginners tutorial. Today's topic is binary search. And the screen capture that I'm using at the moment actually only has a 10-minute limit, so we're going to go through this really quickly. Alright, so binary search. Super simple and super powerful. So what will we cover? Why binary search? How fast is it? Quick demonstration, binary search per pseudocode, and binary search implementation in Java. Alright, so why binary search? Simply, it's good for querying large data sets that have typically been arranged in either ascending or descending order. It's fast, simple, and has many useful applications. So, how fast? Binary search is an O of log n algorithm at worst, where n is the size of the set. Now, if you don't know what O of log n means, just pause the video and do a Google search on Big O, or Big O notation, or asymptotic analysis, and yeah, you don't really need it for this video, but for videos in the future, definitely going to need to understand it. So yeah, simply put, at worst, we'll be doing log n comparisons. Alrighty, so we have a set here, and now we've got 67 in a register up here, and we want to know if 67 exists in this set. So intuitively, we could probably just go, alright, let's build an algorithm that just simply goes 67 equivalent to 20. Nope. 35. Nope. 37. Nope. 40. Nope. 45. Nope. 50. Nope. 51. And yeah, we'll get all the way to 67, and we'll find out that 67 is equivalent to 67, and we will return, yes, it exists in the set. And here's a visual representation of that. As you can see, we've had to do 9 comparisons. If 67 was at the beginning, then we'd only have to do 1, but at worst, we might have to compare 67 to the entire set before we find it. Or if it doesn't exist in the set, then we'll have to do the exact same. It'll be a comparison with everything. And that is why this sort of algorithm is O of n, not O of log n. This is linear time. Alright, now let's see if we can improve this. So we've got 37, and we want to know if 37 exists in the set. And now the good thing about this is the set is ordered. It's in ascending order. So 20 is the smallest, and it's at the beginning, and 67 is the largest. It's at the end. So what we can do is we can just go compare 37 to the middle value. So we'll find the middle value, and then we'll go, is 37 equivalent to this value? If so, return yes, it does exist in the set. Is 37 greater than this value, or is 37 less than this value? Now, on the greater or less than comparisons, I'll show you here. For example, with 45, 37 is less than 45. So now we know that 37 cannot exist in this half of the set. So we can disregard from 45 all the way to the right. We don't need it. So now we know that 37, if it does exist, is between 20 and 40. There we go. And we'll do the same again. We'll find the middle value. And this time it's an even number. So the middle value will be either 1 or 2. Just depends how you implement your algorithm. It's not going to make a difference. This time it's 35, so we compare 35 to 37. 37 is greater than 35, so we disregard 20 and 35. Alright, so now we do it again, and this time the middle value is 37, and yeah, 37 is equal to 37, and it does exist. So, if you were counting, we did 3 comparisons then, compared to the 9 comparisons we had to do before, so yeah, it's a lot better. So therefore, pretty much just went over all this stuff, but yeah, so the first algorithm was O of n. The way we had it implemented is typically known as a brute force algorithm. So we had to compare, at worst, everything to the element of concern, which just isn't good for a big data set. And the second algorithm, binary search, was O of log n, because every comparison we made, we essentially decreased the size of the set by half. Thus, at worst, log n comparisons are made. Now, if you don't fully understand what's happening here, just go back to the previous example and just, yeah, have a look over it. It's pretty simple. So yeah, this is the pseudocode for the first algorithm, the O of n one. And yeah, I'm not going to really go over it too much because it's not really relevant, but if you want to, you can read over it and understand how it works. Simply, you just, yeah, increase the index by 1 each time. And for comparison equals v, then you return yes. And if it doesn't, then yeah, you increase the counter by 1, so I is equal to I plus 1. And eventually, once I is greater than n, and n is the size of the set, this while loop condition is violated, and we'll go straight to the return statement down here, and we'll return no, it does not exist in that set. Alright, this is what I'm really interested in, and this is the pseudocode for binary search. Yeah, I'd suggest if you want to understand binary search, look at the pseudocode rather than looking at an actual language, because this here is just written in pure English. It's really easy to understand, and yeah, once you understand the pseudocode, you can literally just implement it in any language you want. So here's the two-pointer method. So we set the left pointer to 1, which is the beginning of the set, and the right pointer to n. And we set n to be the size of the set. So now this is pointing to the end of the set. So for example, if we have 9 elements, then n equals 9, and we'll be pointing to the 9th element. So while left is less than or equal to right, we set the middle pointer to left plus right divided by 2. And you might be saying, oh, well, what happens if we end up with a decimal? Well, when you implement it, you're obviously going to implement it with integer division, so you're not going to end up with a floating point number, so that's not going to matter. Yeah, so we head down to the if statement now, and we go, if the memory cell at address mid equals v, then return yes, it does exist. Else, if the memory cell at address mid is greater than v, then we head to this and we adjust the right pointer. So now the right pointer is equal to mid take 1. So we've now disregarded that side. Again, if it was the other way around, it'll go to this else statement and we'll adjust the left pointer to mid plus 1, and we'll disregard that side, and we'll just keep doing this until this is violated or this is satisfied. And yeah, that's pretty much it. Again, if you don't understand what's happening down here, this is literally this is how we disregard the part of the set we don't need anymore. Yeah, this is probably the most important part down here. Alright, because we're probably getting low on time, head to the Java implementation here. Again, I'm not going to go through it because it's literally just that, but in Java, but I just thought it would be good to show you what it actually looks like in a language. It looks pretty much the same in C. Yeah. Oh, actually, I should mention, this is an iterative design for binary search. You could do a recursive design as well. It just depends what you prefer. I prefer iterative over recursion because I just haven't been bothered to become comfortable with recursion, so I just prefer this. But yeah, that's it. I'm pretty new to this. This is literally my first video, so if you think I'm doing something wrong, just write a comment. And yeah, try not to speak so fast next time as well, but yeah, I'm on a time limit for this. I need to get a better screen recording software. Yeah, long story, but yeah, this is what I got at the moment. Anyway, like and subscribe for more CS for Beginner tutorials.